Breaking news from NASA's lunar program has sent shockwaves through the space community. The $2 billion Artemis mission, humanity's grand return to the moon, has hit a critical roadblock. As NASA grapples with severe technical challenges and mounting delays, the future of American space exploration hangs in the balance. The story begins with a troubling discovery. After Artemis 1's dramatic return to Earth, engineers uncovered something that would change everything. The spacecraft's heat shield, designed to protect astronauts from the inferno of re-entry, had failed to perform as expected. This wasn't just a minor setback, it was a potential showstopper for the entire program. But while NASA faces these daunting challenges, another player in the space race is writing a different story. SpaceX's Starship program continues to break new ground, achieving milestone after milestone. Their latest triumph? Successfully catching a massive rocket booster with robotic arms as it descended from space, a feat that seemed impossible just years ago. This stark contrast between NASA's struggles and SpaceX's innovations raises crucial questions about the future of space exploration. Will NASA's traditional approach prevail, or is it time for a fundamental shift in how we reach for the stars? The answer could reshape humanity's journey to the moon and beyond. Hello everyone, welcome to Elon Musk 24 Hours. Let's dive right in. The race back to the moon has never been more urgent. As China sets its sights on landing astronauts on the lunar surface by decade's end, a timeline they rarely miss, NASA finds itself at a crucial crossroads. The stakes couldn't be higher, and the challenges couldn't be more daunting. When Artemis 1's Orion spacecraft pierced through Earth's atmosphere in December 2022, it was traveling at a blistering 24,600 miles per hour. That's 39,000 kilometers per hour. The heat shield, designed to protect against temperatures over 5,000 degrees Fahrenheit, would face its ultimate test. While the capsule successfully splashed down in the Pacific Ocean, what engineers discovered in the following days would send ripples of concern throughout the entire space program. The heat shield hadn't just been scorched, it had shed material in ways that the world's top aerospace engineers hadn't predicted. This wasn't just a minor technical glitch, it was a potential catastrophe in waiting. The stakes became crystal clear. If this had happened during a crewed mission, the consequences would have been unthinkable. Charles Camarda, a former astronaut with 45 years of NASA experience, didn't mince words. "I love NASA," he said, his voice heavy with emotion, "but I do not love what NASA has become." This criticism hits particularly hard coming from someone who dedicated nearly half a century to the agency. "We have lost our research culture," he continued, pointing to a fundamental shift in how NASA approaches critical safety decisions. But the heat shield isn't the only ghost haunting NASA's lunar dreams. The Orion spacecraft's side hatch began showing troubling behavior, raising questions about whether astronauts could safely exit in an emergency. The life support system, quite literally the astronaut's lifeline in the cold void of space, revealed valve problems that passed testing for Artemis 2, but failed during Artemis 3 mission simulations. Even the spacecraft's emergency batteries showed concerning performance issues. Perhaps most troubling was the discovery about the heat shield's permeability. In a twist that seems to defy common sense, the shield wasn't permeable enough during Artemis 1. This led to dangerous gas buildup and pressure increases, ultimately causing the cracking that engineers observed. Yet remarkably, the heat shield planned for Artemis 2 is no more permeable than its predecessor. It's a decision that has left many in the space community scratching their heads. Meanwhile, on the ground, another drama unfolds. The mobile launch tower for the Space Launch System, SLS, essentially the backbone of the entire launch operation, has been plagued by its own set of problems. A recent report from the U.S. Government Accountability Office revealed that NASA's Exploration Ground Systems program had burned through all its schedule margin. In plain English, there's no more room for error. This time crunch becomes even more perplexing when you consider that by September, the ground systems team will have had nearly 3 years since Artemis 1 to address these issues. Yet here we are, with zero margin left in the schedule. The contrast with SpaceX's rapid development pace couldn't be starker. Speaking of SpaceX, their Starship program has been putting on quite a show. In October, space enthusiasts worldwide watched in awe as the company's massive booster stage was caught by robotic arms as it descended from the Texas sky. It wasn't just a technical achievement, it was a statement about the future of space travel. While NASA struggles with expendable rockets costing hundreds of millions per launch, SpaceX is pushing the boundaries of reusability. This brings us to a pivotal moment in the story. NASA Administrator Bill Nelson, approaching the end of his term, made a decision that sent shockwaves through the aerospace community. Despite all the concerns about the heat shield, Nelson announced that NASA would proceed with the same design for Artemis 2. The only change? A modified re-entry trajectory. The response was swift and harsh. Expediency won over safety and good materials, science and engineering, wrote one expert on LinkedIn. A sad day for NASA. The criticism points to a deeper issue. Has NASA's desire to maintain its launch schedule begun to overshadow its legendary commitment to safety? Enter Jared Isaacman, a potential future NASA administrator under a new administration. His perspective offers a striking contrast to the current approach. The government does business very differently than the rest of the country, he observed, advocating for a more agile, iterative approach to space exploration. His vision? A world where lower launch costs enable more experimentation and risk-taking, leading to faster innovation. But here's where the story takes another turn. The suggestion to simply cancel SLS and replace it with SpaceX's Starship isn't as straightforward as it might seem. Starship could theoretically serve as both launcher and lunar lander, a tantalizing possibility that could revolutionize deep space travel. However, the transition would face enormous technical, logistical, and political hurdles. Consider this. No commercial launch company, not even SpaceX, has demonstrated the operational readiness to take on something of this magnitude. The Artemis program isn't just about returning to the moon, it's about establishing a sustainable presence on our celestial neighbor, particularly in the resource-rich South Pole region. This requires a level of precision, reliability, and scalability that's unprecedented in human spaceflight. The Falcon Heavy rocket has been suggested as another alternative for launching Orion, but this too comes with its own set of challenges. The modifications required would be extensive, requiring new human rating certifications and compatibility adjustments. In the race against time and China, these changes could lead to even more delays. As we stand at this critical juncture, the decision facing NASA isn't just about rockets and heat shields. It's about America's role in the future of space exploration. The agency finds itself caught between its traditional methods and the innovative approaches of the commercial space sector. The coming months will determine whether NASA can adapt and evolve while maintaining its commitment to safety and success. The pressure is mounting. China's space program moves forward with characteristic precision, while NASA grapples with technical challenges and mounting delays. The decisions made in the next few months won't just affect the Artemis program, they'll shape the future of human space exploration for generations to come. For those who dream of seeing humans return to the moon, the path forward remains uncertain. Will NASA's traditional approach prevail, or will commercial innovation reshape our journey to the stars? The answer lies not just in technical specifications and budget allocations, but in our collective will to push the boundaries of what's possible. As we look to the future, one thing becomes clear. The success of America's return to the moon depends not just on solving technical challenges, but on finding the right balance between innovation and safety, between speed and reliability, between tradition and transformation. The clock is ticking and the world is watching. The next few months will be decisive for America's lunar ambitions. As NASA weighs its options between maintaining its current course with SLS or embracing new commercial alternatives, one truth remains clear. The path back to the moon will require both courage and innovation. The story of Artemis isn't just about rockets and heat shields. It's about humanity's unwavering desire to explore the unknown. Whether through NASA's traditional approach or SpaceX's revolutionary methods, the goal remains the same: to establish a sustainable human presence on the moon and pave the way for even greater adventures beyond. The space race of the 21st century demands not just technological prowess, but the wisdom to know when to hold course and when to chart a new path. As we've seen, the stakes couldn't be higher, and the challenges couldn't be more complex. If you're as passionate about space exploration as we are, make sure to hit that subscribe button and join our growing community here at Elon Musk 24 Hours. Share your thoughts in the comments below. Do you think NASA should stick with SLS, or is it time for a bold new approach? Your perspective matters in this ongoing conversation about humanity's future in space. Thanks for watching, and we'll see you in our next deep dive into the world of space exploration. At Starbase, Texas, a rocket taller than the Statue of Liberty descends from the sky at breathtaking speed. In less than a decade, SpaceX has revolutionized the space industry by doing what seemed like science fiction, catching rockets in midair. The mechanical arms of Mechazilla extend from the launch tower like a high-stakes game of catch, representing one of the boldest innovations in spaceflight history. But even groundbreaking technologies have their limitations. As SpaceX pushes the boundaries of what's possible, they've discovered that sometimes the most elegant solutions aren't always the most practical ones. Today, we'll explore how SpaceX is rethinking their approach to landing both Starship and its Super Heavy booster. This strategic shift could completely transform how we recover the world's most powerful rocket, making space travel more efficient and reliable than ever before. From the Elon Musk 24-hour channel, let's dive right in. The story of catching rockets begins with an elegant but incredibly complex idea. When SpaceX first unveiled their vision of Mechazilla's mechanical arms gracefully plucking Starship boosters from the sky, it captured the world's imagination. Those towering steel arms, reaching into the heavens like modern-day titans, represented humanity's growing mastery over spaceflight technology. But as with many ambitious innovations in the space industry, the reality proved far more challenging than anyone anticipated. The forces at play during a rocket landing are staggering. When Super Heavy, Starship's first stage booster, returns from the edge of space, it's not just fighting gravity, it's wrestling with complex aerodynamics, battling atmospheric turbulence, and managing the tremendous energy of its descent. Every landing attempt is a delicate dance between raw power and precise control. The 33 Raptor engines, each capable of producing 520,000 pounds of thrust, must work in perfect harmony to guide this massive structure to its target. The original Mechazilla concept faced three critical challenges that pushed SpaceX to reconsider their approach. First, there's the issue of timing. Catching a descending rocket requires split-second precision, the kind of accuracy that leaves absolutely no room for error. Even a fraction of a second's delay or a slight misalignment could spell disaster for both the booster and the catching mechanism. It's like trying to catch a falling pencil by its point, except this pencil weighs millions of pounds and is moving at tremendous speeds. Second, there's the weather factor. While the Texas coast might seem like an ideal launch location, its unpredictable wind patterns create a constant challenge. The slightest gust can push the massive rocket off course during its final descent, making a successful catch nearly impossible. These environmental variables added another layer of complexity to an already intricate operation. The third challenge involves the immense forces at play during the catching maneuver. When Super Heavy descends, it carries an enormous amount of kinetic energy that must be safely absorbed and dissipated during the catch. The mechanical arms need to be strong enough to handle these forces while remaining flexible enough to prevent damage to the booster. It's an engineering paradox that has proven extremely difficult to resolve, but SpaceX has never been a company to back down from a challenge. Instead of abandoning the idea of rocket recovery altogether, they've begun exploring a hybrid approach that combines the best aspects of their previous experiences with new innovations. Drawing from their successful history with Falcon 9 landings, they're developing an enhanced drone ship system specifically designed for Starship's unique requirements. These next-generation drone ships represent a significant evolution in rocket recovery technology. Unlike their predecessors, which were designed for the relatively modest Falcon 9, these new vessels must handle a rocket that's nearly 10 times heavier and generates 10 times more thrust. The engineering challenges are immense, but the potential benefits make the effort worthwhile. Consider the numbers. Starship, when fully stacked with its Super Heavy booster, stands 120 meters tall with a diameter of 9 meters. When fueled, it weighs nearly 11 million pounds, a mass that dwarfs anything previously attempted to land at sea. The drone ships needed to recover such a behemoth must be technological marvels in their own right. SpaceX's engineers are tackling these challenges with innovative solutions. The new landing platforms will feature advanced stabilization systems that can compensate for ocean movements, crucial for maintaining a stable landing surface. They're developing cutting-edge heat shielding materials to protect the ships from the intense heat generated by Starship's Raptor engines, which burn hotter and more efficiently than the Falcon 9's Merlin engines. But perhaps the most impressive innovation is the advanced water deluge system being developed for these new drone ships. This system must deliver precisely controlled water flows to cool the landing pad and manage the tremendous